Hey y'all, today I'm going over one of my favorite problems on Leetcode, unique paths. Actually, this is one of the few that I use to teach people DP. So yes, this has a DP solution. But first, let's go over the problem and what it asks. So basically, there's a grid, an n by n grid, and robot at the top left, it has to get to the bottom right. And you have to return all the possible ways that the robot can get to the bottom right. And a way is just like a different configuration of the way that it moved across the grid to get to the finish. So I'll kind of explain why the intuition behind this and why DP works for this. If you're not sure about what DP is, there's probably better videos, and maybe I'll make one that explains it a little better one time. But it's just a way of breaking a problem into smaller sub problems, and you might hear that in every explanation, but I'll kind of explain what it means. So let's assume that you have this robot over here, and let's assume that this is the grid, and I'll try to do this small like this, and let's assume that it has to get to the X. So basically, when I say subproblems, you can think of it like how many unique ways does it take to get to this cell directly to the right? There's only one way, and that is from the left, right? And here, going down, there's only one way, and that is from the top. And remember from this problem, it can only move down or right at any point of time. And in fact, if we look down to this cell, there's only one way. And this cell, there's only one way. And all over here, there's only one way over here, because it can only, on this first row, it can only come from the left. There's no other way to reach those cells. So anyways, that's kind of how you do it. And then also the same logic applies on the first column. So when we have this, then we actually just broke the problem into smaller subproblems, because think about this. We changed the problem from being how many unique ways to get to the bottom right to how many unique ways to get to this cell right here. We actually do that for every single cell. So this cell right here, how many unique ways to get from this cell? If you think about it, it can only come from the top or the left. But this way had one unique way, and this way had one unique way. So how many unique ways? It's just two. And what did we do? We just added them. That's all. And then for here, it's just three. Because, two from the left or one from the right. And then you keep building and you keep building and you keep doing that. And then there's kind of like this pattern. And you go like that and you go like that. And then it's 6. And then it's 10, 15, 21, 10, 20, 35. And then the final answer for this problem right here, this isn't the same grid size as the other one, so it won't be the same. But this one is 56 is the final answer. And yeah, that's literally kind of how it looks like. And that's why DP works for this. And the reason why we use DP is because we can break this into smaller subproblems. Like, look, at the end of the day, we can make the grid this. It's a subproblem. It's a sub portion of the grid. And the answer to this cell is 6 at this moment. So you just solve the problem for every single cell until you get to the cell that you want. So that's kind of why we use DP, and that's why DP works for all these kind of things. But identifying that is the difficult part, certainly. It looks like mine actually had more ways because my grid was actually bigger than this one, but that's fine. So anyways, I will do exactly what I just explained on the whiteboard. So we'll initialize a DP. So a DP array, and it's going to be M and N in dimensions, because it's literally the same size as the grid. We already know one thing. We are going to return what's at the bottom right, because if you remember my explanation over here, the answer should be in the bottom right when we're done building that. Also, one other pattern that we have to take care of is, if you noticed here, the whole top column is 1, and the whole top row is 1, and the whole first column is 1 as well. So let's just get rid of that right away. So what we can do is, for int I is less than m, let's just fill those with whatever. So this will be the first. Sorry, I'm struggling. So I will be the row, right? So dpi of 0 is equal to just make this a 1. So following that same logic, and then we copy this down, and let's do the same for j, like this, and that takes care of our case that I was just discussing. And let's make this a j instead. Okay, so then what these two things do is just this, right? These ones across the column and the row. Next, we build the rest of our DP, and this time because we've taken care of the first column and the first row, we can start at 1 here because we already did that. So let's go like that, and let's go like this. Build the rest, right? So then what was it over here? Just remember, it was we just add the top and the left. So let's just literally do that. So the DP result at the current cell is simply the top cell plus the left cell. So same row, j minus 1, like that. And that's literally the same logic. And we run this, and for some reason, it's out of bounds. Why is it out of bounds? Because I think I messed this up pretty brutally. Why is it? Oh, sorry, this is supposed to be n, my bad. J less than n. Okay, we run this, and then we submit this. And then yeah, beats 100%. Let's talk about the time complexity and the space complexity. There are alternative solutions. You could probably do backtracking, you could do some crazy recursive thing, but this here, if we look at the time, we're not doing anything crazy. Like this is a loop bound to m, this is a loop bound to n, and this is a loop bound to m and n. So literally it's actually just O m n. That's all we have to do is just loop through m and loop for each m, loop through n. So time is O and n, and space is also O, m, and n because we're using a DP array, right? So yeah, hope this made sense, and I hope I made it a little less complicated. I don't want to make a massive video on DP, but I tried to disambiguate it a little bit. So yeah, hope you enjoyed.